MyBatis Architecture. Here you can see MyBatis architecture diagram. MyBatis is a Java persistent framework that couples objects with stored procedures or SQL statements using an XML descriptor or annotations. Now we are focusing on configuration. The MyBatis configuration contains settings and properties that have a dramatic effect on how MyBatis behaves. The high-level structure of the document is as follows: configuration, properties, settings, type, aliases, type handlers, object factory, plugins, environment, transaction manager, data source, database ID provider, and mappers. As an example, we can consider invalid configuration exception. This is in the package org.mybatis.generator.exception. As an exception example 2, we can consider SQL session exception. This can occur in settings auto mapping unknown column behavior. If there's a fail mapping, it can throw SQL session exception. Now we are focusing on mapper annotations. Since the very beginning, MyBatis has been an XML driven framework. The configuration is XML based and the mapped statements are defined in XML. With MyBatis 3, there are new options available. MyBatis 3 builds on top of a comprehensive and powerful Java-based configuration API. This configuration API is the foundation for the XML-based MyBatis configuration, as well as the new annotation-based configuration. Annotations offer a simple way to implement simple mapped statements without introducing a lot of overhead. As an example, we can consider this. This example shows using select key annotation to retrieve value from a sequence before an insert. Annotation insert, the annotation that specify an SQL for inserting records. Annotation select key, the annotation that specify an SQL for retrieving a key value. As an error example, we can consider this: cannot use both ampersand at and ampersand many annotations in the same ampersand result. This error occurred in MyBatis 3.2.6. Now we are focusing on SqlMapConfig.xml as a global configuration file of MyBatis configures the running environment of MyBatis and other information. Here you can see the hierarchical structure of MyBatis configuration file. Basically, we need to master the configuration of nine top level elements, including tags orange, red, because it involves plugin unit and dynamic SQL plugin in configuration can be applied to pagination and function enhancement. Dynamic SQL such as if tag, where tag, for each tag is primarily understood to be applied to SQL statement splicing. Properties. These are externalizable substitutable properties that can be configured in a typical Java properties file instance or passed in through sub-elements of the properties element. Settings. These are externally important tweaks that modify the way that MyBatis behaves at runtime. Type aliases. A type alias is simply a shorter name for a Java type. It's only relevant to the XML configuration and simply exists to reduce redundant type of fully qualified class names. Type handlers. Whenever MyBatis sets a parameter on a prepared statement or retrieves a value from a result set, a type handler is used to retrieve the value in a means appropriate to the Java type. Object factory. Each time MyBatis creates a new instance of a result object, it uses an object factory instance to do so. The default object factory does little more than instantiate the target class with a default constructor or parameterized constructor if parameter mappings exist. If you want to override the default behavior of the object factory, you can create your own. Plugins. MyBatis allows you to intercept calls at certain points within the execution of a mapped statement. By default, MyBatis allows plugins to intercept methods calls of executor, update, query, flush statements, commit, rollback, get transaction, close is closed, and parameter handler, get parameter object, set parameters, result set handler, handle result set, handle output parameters, statement handler, prepare, parameterize, batch, update, query. The details of this classes methods can be discovered by looking at the full method signature of each and the source code which is available with each MyBatis release. You should understand the behavior of the method you are overriding, assuming you are doing something more than just monitoring calls. If you attempt to modify or override the behavior of a given method, you are likely to break the code of to break the core of MyBatis. These are low-level classes and methods, so use plugins with caution. Environments. MyBatis can be configured with multiple environments. This helps you to apply your SQL maps to multiple databases for any number of reasons. For example, you might have a different configuration for your development, test and production environments, or you may have multiple production databases that share the same schema and you would like to use the same SQL maps for both. There are many use cases. It is an important thing to remember though, while you can configure multiple environments, you can only choose one per SQL session factory instance. You can see the environment here and transaction manager. There are two transaction manager types. That is type equal JDBC or manage that are included with MyBatis. JDBC. This configuration simply makes use of JDBC commit and rollback facilities directly. It relies on the connection retrieved from the data source to manage the scope of the transaction. Managed, this configuration simply does almost nothing. It never commits or roll back a connection. Instead, it lets the container manage the full lifecycle of the transaction. That is a JEE application server context. By default, it does close the connection. However, some containers don't expect this, and thus, if you need to stop it from closing the connection, set the close connection property to false. Data source. The data source element configures the source of JDBC connection objects using the standard JDBC data source interface. Database ID provider. MyBatis is able to execute different statements depending on your database vendor. The multi-DB vendor support is based on the mapped statement database ID attribute. MyBatis will load all statements with no database ID attribute or with a database ID that matches the current one. In case the same statement is found with and without the database ID, the latter will be discarded. Mappers. Now that the behavior of MyBatis is configured with configuration elements, we are ready to define our mapped SQL statements. But first, we need to tell MyBatis where to find them. Java doesn't really provide any good means of auto discovery in this regard, so the best way to do it is to simply tell MyBatis where to find the mapping files. You can use class path relative resource references fully qualified URL references including file colon / / URLs, class names or package names. Here you can see a sample mapper.xml and mapper.xml files have only a few first class elements. Cache, configuration of the cache for a given namespace, cache ref, reference to a cache configuration from another namespace, result map, the most complicated and powerful element that describe how to load your objects from the database result sets. Parameter map is deprecated. Old school way to map parameters. Online parameters are preferred and this element may be removed in the future. Not documented now. And SQL, a reusable chunk of SQL that can be referenced by other statements. Insert, a mapped insert statement. Update, a mapped update statement. Delete, a mapped delete statement. Select, a mapped select statement. And here you can see SQL also. And here you can see a MyBatis-config.xml file here as example, and you can see properties. This file is linked with is connected to properties, settings, type aliases, type handlers, object factory, plugins, environments, database, ID provider, and mappers. Environments are connected to transaction manager and data source, and this has one environment here. And mappers are connected to cache ref, result map, parameter map, SQL, insert, update, delete, select, and SQL. Here we are considering one mapper file here, mapper.xml. Here you can see a complete MyBatis the configuration file structure. Note that when writing in this order, you should also configure it in this order. Here you can see doc type part and the root element of the configuration file here. Attribute define configuration externalization here, and set up the definition MyBatis some global settings, specific parameter name and parameter value, type the name, define aliases for some classes, type processor, definition the Java conversion relationship between a type and a data type in a database, object factory, plugin unit, MyBatis plugin for plugin can be modified, and MyBatis internal operation rules of environmental science to configure MyBatis environment. Environment variable, multiple environment variable can be configured. For example, when using multiple data sources, you need to configure multiple environment variables. Transaction manager, data source, and database vendor identification, mapper, specify the mapping file or class. As an example, you can see here simple example of the configuration file. The configuration XML file contains settings for the core of MyBatis system, including data source for acquiring database connection instances, as well as transaction manager for determining how transactions should be scoped and controlled. While there is a lot more to the XML configuration file, this example points out the most critical parts. Notice the XML header required to validate XML document. The body of the environment elements contains the environment configuration for transaction manager and connection pooling. The mappers elements contains a list of mappers. The XML files and or annotated Java interface classes that contain SQL code and mapped definitions. As an exception example, we can consider this caused by org.springframework.core.nested.io exception. Failed to pass config resource servlet context resource /web-inf/SqlMap.xml. Nested exception is com.ibatis.common.xml.node exception error passing XML. Cause java.lang.runtime exception error passing XPath /SqlMapConfig/SqlMap. Cause java.io.io exception could not find resource web-inf/ad campaign details SqlMap.xml. This error occurred in Spring and MyBatis environment. This as an error example, we can consider this: could not open servlet context resource /MyBatis/SqlMap.config.xml. This error occurred in SSM framework. Now we are focusing on SqlMap.xml. Serves as the SQL mapping file of MyBatis is configured with SQL statement to operate the database. This file needs to be loaded in SqlMapConfig.xml. As an example, you can see here sample account.xml file in MyBatis 2.x version. You can see SqlMap and namespace here, and you can see a result map here. the most complicated and powerful element that describe how to load your object from the database result sets. You can see ID here, and ID result, flagging result as ID with help improve overall performance. Both ID and result map a single column value to a single property or field of a simple data type, string, int, double, date, etc. And you can see attribute property here in result, a field or property to map the column result to, and the column name from the database or the aliased column label, and column index here. We can see a select element here, a mapped select element, an ID, a unique identifier in this namespace that can be used to reference the statement. The result map, a named reference to an external result map here. And you can see here insert element, a mapped insert statement, ID is here, and ID attribute, a unique identifier in this namespace that can be used to reference this statement. Here, as an example too, you can see here in MyBatis a mapper.xml file, sample one. Here mapper namespace is user. Here you can see a select element, a mapped select statement. Here you can see ID, a unique identifier in this namespace. That can be used to reference this statement. We can see here a parameter type, a fully qualified class name or alias for the parameter that will be passed into the statement. And the result type, the fully qualified class name or alias for the expected type that will be returned from the statement. Here you can see insert element, a mapped insert statement. You can see ID here, ID attribute, a unique identifier in this namespace that can be used to reference this statement. Parameter type, the fully qualified class name or alias for the parameter that will be passed into this statement. flush cache attribute settings this to be to true will cause the second level and local caches to be flushed whenever this statement is called. Default true for insert, update and delete statement. Timeout attribute, this sets the maximum number of seconds the driver will wait for the database to return from a request before throwing an exception. Default is unset, driver dependent. A configuration file for MyBatis 2 look like this, and remember that MyBatis loads resources from the class path, so be sure to add the account.xml file to the class path. Here in MyBatis, using class path relative resources, this statement simply tell MyBatis where to go from here. The rest of the details are in each of the SQL mapping files. This segment is from SqlMapConfig.xml. As an exception example, we can consider class SqlMapException thrown to indicate a problem with SqlMap configuration or state. Generally, if an SqlMap exception is thrown, something is critically wrong and cannot be corrected until a change to the configuration or the environment is made. Note, generally this wouldn't be used to indicate that an SQL execution error occurred. That's what SQL exception is for. This is in the package com.mybatis.sqlmap.client. As an error example, we can consider this. The error may exist in MyBatis/student.xml. The error occurred while processing mapper_result. This error occurred in Spring using MyBatis. Now we are focusing on mapper. Mappers are interfaces that you create to bind to your mapped statements. Instances of mapper interfaces are acquired from the SQL session. As such, technically, the broadest scope of any mapper instance is the same as the SQL session from which they were requested. However, the best scope for mapper instances is method scope. That is, they should be requested within the method that they are used and then be discarded. They do not need to be closed explicitly, while it's not a problem to keep them around throughout the request. Similar to the SQL session, you might find that managing too many resources at this level will quickly get out of hand. Keep it simple, keep mappers in the method scope. Here you can see MyBatis lifecycle and scope. It is very important to understand the various scope and lifecycle classes. Using them incorrectly can cause severe concurrency problems. Dependency injection frameworks can create thread-safe transactional SQL sessions and mappers and inject them directly into your bean, so you can just forget about their life cycle, you may want to have a look at MyBatis-Spring or MyBatis Goose sub-project to know more about using MyBatis with DI frameworks. Here you can see MyBatis-config.xml. Here you can see a SQL session factory builder. This class can be instantiated, used, and thrown away. There is no need to keep it around once you have created your SQL session factory. Therefore, the best scope for instances of SQL session factory builder is method scope, that is a local method variable. You can reuse the SQL session factory builder to build multiple SQL session factory instances, but it is still best not to keep it around to ensure that all of the XML parsing resources are freed up for more important things. SQL session factory. Once created, the SQL session factory should exist for the duration of your application execution. There should be little or no reason to ever dispose of it or recreate it. It's a best practice to not rebuild the SQL session factory multiple times in an application run. Doing so should be considered a bad smell. Therefore, the best scope of SQL session factory is application scope. This can be achieved a number of ways. The simplest is to use a singleton pattern or static singleton pattern. SQL session. Each state should have its own instance of SQL session. Instances of SQL sessions are not to be shared and are not thread safe. Therefore, the best scope is request or method scope. Never keep references to a SQL session instance in a static field or even an instance field of a class. Never keep references to a SQL session in any sort of managed scope, such as HTTP session of the servlet framework. If you are using a web framework of any sort, consider the SQL session to follow a similar scope to that of an HTTP request. In other words, upon receiving an HTTP request, you can open a SQL session, then upon returning the response, you can close it. Closing the session is very important. You should always ensure that it's closed within a finally block. Following is a standard pattern for ensuring that SQL sessions are closed. Try open bracket SQL session equal SQL session factory dot open session open bracket close bracket open curly bracket, and do the work and close curly bracket. Using this pattern throughout your code will ensure that all database resources are properly closed. Mappers are instances that you create to bind your mapped statements. Instances of mapper interfaces are acquired from SQL session. As such, technically a broader scope of any mapper instance is the same as the SQL session from which they were requested. However, the best scope for mapper instances is method scope. That is, they should be requested within the method that they are used and then be discarded. They do not need to be closed explicitly. While it's not a problem to keep them around throughout a request. Similar to the SQL session, you might find that managing too many resources at this level will quickly get out of hand. Keep it simple. Keep mappers in the method scope. Here you can see MyBatis -config.xml file is connected to SQL session factory builder. SQL session factory builder is connected to SQL session factory. SQL session factory is connected to SQL session, and SQL session is connected to SQL mapper. As an example, we can consider this one. Here this statement is called select person, takes a parameter of type int or integer and return a HashMap keyed by column names mapped to row values. The statement select mapped select statement here attribute ID, a unique identifier in this namespace that can be used to reference this statement. The attribute parameter type int, parameter type here a fully qualified class name or alias for the parameter that will be passed into the statement. This attribute is optional because MyBatis can calculate the type handler to use out of the actual parameter passed to the statement. Default is unset, and result type, the fully qualified class name or alias for the expected type that will be returned from this statement. Note that the case of collections, this should be the type of collection contains, not type of the collection itself. Use result type or result map, not both. This example shows using @select key annotation to retrieve a value from a sequence before insert. Here annotation insert, the annotation that specify a SQL for inserting records. Here this value returns an SQL for inserting records here. Here annotation select key, As an example 3, you can see mapper instances here. This block mapper is in package org.apache.ibatis.domain.block.mappers. As an exception, we can consider binding exception. It's in package org.apache.ibatis.binding. As an error example, we can consider invalid bound statement not found. Now we are focusing on mapped statement. Map statement can hold any SQL statement and can use parameter maps and result maps for input and output. Here you can see how to communicate SQL written in XML, SqlMap.xml in MyBatis with DB. In the way of programming using existing JDBC, SQL statements were written in the program source, but using MyBatis, the SQL statements are separated from the program and written separately in XML file. This reduces the burden of programmers programming when using existing JDBC. In addition, if the user wants to change the SQL can be changed freely because the user only needs to change the SQL statement in the SQL files in the XML file rather than modifying the program as before. When user writes the each SQL statement for CRUD in SqlMap.xml XML file and writes these files in SqlMap.config.xml file, it automatically create mapped statements objects through MyBatis API and execute SQL statements in DB through it. Here you can see parameter objects as input. Java bean map, HashMap to tree map, primitive integer string, and XMLs are connected to SqlMap. SqlMap.xml is connected to SqlMapConfig.xml and SqlMapConfig.xml is connected to SqlMap. SqlMap has mapped statements and SqlMap interacts with JDBC, and results objects are here as outputs. Java bean mapped, HashMap, tree map, primitive integer string, etc. and XML are connected to SqlMap. As an example, we can consider this mapped statement: select a string from person where ID equal hash ID. This statement is called select person and takes a parameter of type int or integer and returns a HashMap keyed by column names mapped to raw values. As an example 2, we can consider this. This example shows using the select key annotation to retrieve value from sequence before in an insert. Here the annotation type insert the annotation that specifies SQL for inserting record. Here's the map statement, and annotation type select key, the annotation that specify the SQL for retrieving a key value here. As an example 3, we can consider this code segment. MyBatis allows you to intercept calls at certain points within execution of a mapped statement. This annotation type intercept, the annotation that specify target methods to intercept, and this is in package org.apache.ibatis.plugin. This annotation type signature, the annotation that indicate the method signature. The type element is returns the Java type, and method returns the method name, and args returns Java types for method arguments. And here implements pre-processing if needed, and implement post-processing if needed here, before and after invocation proceed. As an exception example, we can consider this occurred in Spring and MyBatis. Java.land.illegal argument exception. Mapped statement collection does not contain value for com.thong.lm1.spring.mappers.ordermappers.get all order at org.apache.ibatis.session.configuration $strictmap.get configuration.java 672 org.apache.ibatis.session.configuration.get mapped statement configuration.java 5 or 6 at etc. As an array example, we can consider this. Mapped statement collection does not contain value for mapper .batch customer .find batch customer 1-to-1. Now we are focusing on HashMap and dictionary as input. HashMap, hash table based implementation of the map interface. This implementation provides all of the optional map operations and permits null values and the null key. The HashMap class is roughly equivalent to hash table, except that it is unsynchronized and permits nulls. This class makes no guarantees as to the order of the map. In particular, it does not guarantee that the order will remain constant over time. Dictionary. The dictionary class is the abstract parent of any class, such as hash table, which maps keys to values. Every key and every value is an object. In any one dictionary object, every key is associated with an at most one value. Given a dictionary and a key, the associated element can be looked up. Any null object can be used as a key and as a value. Here you can see the difference between HashMap and hash table in Java. The HashMap and hash table both are used to represent a group of objects that are represented in key value pair. Each key value pair is called entry object. The collection of entries is referred by the object of HashMap and hashtable. Keys in a collection must be unique or distinctive. The difference between HashMap and hashtable is that HashMap particularly implements the map interface, whereas the hashtable extends the dictionary class legacy class, which is re-engineered to implement map interface. The other important difference is that objects of HashMap are unsynchronized, whereas the objects of hashtable is synchronized. As an example, we can consider this one. The value of key in a map can be obtained without adding value characters such as hash and dollar in text expression, while the value of the value of a key in a map can be obtained by writing directly like this, while in other places it is necessary to have hash key in a map to obtain the value of key in a map. Pre-name code and class equal HTML. Yeah. The map parameter passed to MyBatis in the background don't dwell into function meaning. It is enough to know that the following map is finally passed to parameter type in MyBatis. Parameter type attribute, the fully qualified class name or alias for the parameter that will be passed into the statement. This attribute is optional because MyBatis can calculate the type handler to use out of the actual parameter passed to the statement. Default is unset. As an error example, we can consider this one. Type handler was null on parameter mapping for property underscore frch underscore item underscore 0 dot value. It was either not specified or could not be found for the Java type JDBC type combination specified. Now we are focusing on Java or .NET objects as input. Java object. A Java object is a member, also called an instance of a Java class. .NET object. An object is an instance of a particular class. As an example, we can consider this one. If a parameter object of a type user was passed into that statement, the ID, username and their username and password property would be looked up and their values passed into a prepared statement parameter. As an example 2, we can consider this segment. This is Oracle sequence example using .NET 1.1 system.data.oracle client. So this is a .NET example. And here parameter class is product here. Now we are focusing on primitive or simple as input string int, string, date, etc. Int Java type is java.lang.long. CLR type is system.int64. String Java type is java.lang.string. CLR type is java system.string. Date Java type is java.sql.date in general. CLR type is system.datetime. As an example, we can consider this one. This statement is called select person, takes a parameter of type int, and returns a HashMap keyed by column names mapped to raw values. Here the parameter type is int and corresponding Java type is java.lang.long. As an example 2, we can consider this. Here the Java type is java.lang.long. An annotation type param, the annotation that specify the parameter name. Here returns the parameter name. Here it int, and Java corresponding Java type is java.lang.long. As an example 3, we can consider this one. Here the corresponding Java type is java.lang.string, and this parameter is string. As example 4, we can consider this. Parameter type is date, and corresponding Java type is generally java.sql.date. Here, as an error example, we can consider this. Cause com.mysql.jdbc.mysql data truncation, Java truncation incorrect, date time value 3892-04-19 00:00:00 for column register underscore time at row 1. As an output, now we are considering HashMap and dictionary as output. HashMap, hash table based implementation of the map interface. This implementation provides all the optional map operations and permits null values and null key. The HashMap class is roughly equivalent to hash table, except that it is unsynchronized and permits nulls. This class makes no guarantees as to the order of the map. In particular, it does not guarantee that the order will remain constant over time. Dictionary. The dictionary class is the abstract parent of any class, such as hash table, which maps keys to values. Every key and every value is an object in any one dictionary object. Every key associated with at most one value. Given a dictionary and a key, the associated element can be looked up. Any non-null object can be used as a key and as a value. Here you can see the difference between HashMap and hash table in Java. HashMap and hash table both are used to represent a group of objects that are represented in key value pair. Each key value pair is called entry object. The collection of entries is referred by the object of a HashMap and hash table. Keys keys in a collection must be unique or distinctive. Difference between HashMap and hash table is that HashMap particularly implements the map interface, whereas the hash table extend the dictionary class, legacy class, which is re-engineered to implement map interface. The other important difference is that objects of HashMap are unsynchronized, whereas the objects of hash table are synchronized. As an example, we can consider this. This statement simply result in all columns being automatically mapped to keys of a HashMap as specified by the result type attribute result type, the fully qualified class name or alias for the expected type that will be returned from this statement. Note that in the case of collections, this should be the type that the collection contains, not the type of the collection itself. Use result type or result map, not both. As an error example, we can consider this. Expected one result or null to be returned by select one but found, etc. This error was returned while returning HashMap of result in MyBatis rather than list. Now we are focusing on Java or .NET object. Java object is a member, so-called an instance of a Java class. .NET object, an object is an instance of a particular class. As an example, we can consider this one. A Java bean could be mapped to a result set just as easily as the HashMap. Here you can see user. As example 2, we can consider this one. This is an .NET object in .NET platform. The result class is class.name or alias. Now we are focusing on primitive or simple int, string, date, etc. Int, these are as outputs. Int corresponding Java type is java.lang.long. Corresponding CLR type is system.int64. String Java type is java.lang.string. CLR type is system.string. Date Java type is java.sql.date generally. CLR type is system.datetime. As an example, we can consider this. Here in the int, here corresponding Java type is java.lang.long. As an example 2, we can consider this one string. Here corresponding Java type is java.lang.string. As an example 3, we can consider this one. The corresponding Java type is java.sql.datetime generally. Here date. As an error example, we can consider this. Could not set property output of a class java.lang.integer with value 55 cause org.apache.ibatis.reflection exception. There is no setter for the property named output in class java.lang.integer. Now we are focusing on RDBMS, a database management system, DBMS, based on the relational model. Here you can see how does it work. The MyBatis data mapper framework will help you to significantly reduce the amount of Java code that you normally need to access the relational database. MyBatis simply maps the Java beans to SQL statement using a very simple XML descriptor. Simplicity is the key advantage of MyBatis over other frameworks and object-oriented mapping tools. To use MyBatis Java mapper, you need to be familiar with Java beans, XML, and SQL. There's very little else to learn, and there's no complex scheme required to join tables to execute complex queries. MyBatis data mapper API allows programmers to easily map Java beans object to prepared statements, parameters, prepared statement parameters, and result sets. Philosophy behind that data mapper is simple. Provide a simple framework to provide 80% of JDBC functionality using 20% of the code. This is how does it work. Data mapper provide a very simple framework for using XML descriptors to map Java beans, map implementations, and primitive wrappers using string, integer, etc., and even XML documents to an SQL statement. Following is the high-level description of the lifecycle. Provide an object as a parameter, either a Java bean, map, or primitive wrapper. The parameter objects will be used to set input values for the update statement or where close values in a query, etc. Execute the map statement. This step is where the magic happens. The data mapper framework will create a prepared statement instance, set any parameters using the provided parameter object, execute the statement, and build a result object from the result set. In case of the update, the number of rows affected is returned. In case of a query, single object or collection of objects is returned. Like parameters, return objects can be a Java bean, a map, or a primitive type wrapper, or XML. Here you can see an example code here using Java ORM with PostgreSQL. The named file is MyBatis-config.xml here. Here you can see the driver value org.postgresql.driver here, and URL is here. Here the as an example 2, we can consider this one. The environment element define how the environment is configured. Notice the key sections here. The default environment ID, for example, default equal development. The environment ID for each environment defined. So this is the default environment ID, and this is the environment ID for each environment defined. The transactional the transaction manager configuration, type equal JDBC here. Data source configuration, type equal pooled. Default environment and the environment IDs are self explanatory. Name them whatever you like, just make sure the default matches one of them. Transaction manager. There are two transaction manager types, that is JDBC and managed, that are included with MyBatis. Here JDBC, this configuration simply makes use of JDBC commit and rollback facilities directly. It relies on the connection retrieved from the data source to manage the scope of the transaction. Here you can see the data source. The data source element configures the source of JDBC connection object using the standard JDBC data source interface. Most MyBatis applications will configure the data source as an however, it is not required to there are three built-in data source types: unpooled, pooled, and JNDI. Here is pooled. This implementation of data source pools JDBC connection objects to avoid the initial connection and authentication time required to create a new connection instance. This is the popular approach for concurrent web applications to achieve the fastest response. Here you can see driver property name. This is the fully qualified Java class of the JDBC driver, not of the data source class. If your driver includes one URL, this is the JDBC URL for your database instance. Username, the database username to log in with. Password, the database password to log in with. This is a sample SqlMap.config for .NET web application. Place this file in same directory as web.config. Here you can see database, provider name SQL Server 1.1, data source name npet shop, connection string here, password here, data source here, database here. As an exception example, we can consider this: org.apache.ibatis.exceptions, persistent exception, error querying database, cause java.sql syntax error exception, etc. As an error example, we can consider this: you have an error in your SQL syntax. Check the manual that correspond to your MySQL server version for the right syntax to use near create temporary table temp underscore role underscore id int insert into temp underscore role underscore id va at line 2. This is end of my presentation. Thank you very much for watching it.